G'day guys, we've got a basic calculus question here today where we've got a quadratic function which cuts the x-axis in two places. We've got to find the coordinates of each of these points and determine the gradient of the curve at each one. Okay, so first of all what we're going to do is we're going to find out what our x-intercepts of this curve are. And to do that, I can see this is a monic quadratic equation, so I'm just going to factorize it. So I'm looking for two numbers that add together to give -2 and multiply together to give -15. So we're going to have our function is going to be y equals, now I'm going to factorize this like this, x minus 5, x plus 3. And so this factorized, if I multiply this out of the brackets, I will get the one above. Now using the null factor law, I can set this equal to 0 to find our x-intercepts, and we get the coordinates of each of our points as 5, 0 and -3, 0. Now the null factor law just states if you've got two numbers multiplied together to that equals 0, at least one of them has to be 0. And so from there we can come out with this. Now from here we need to go and work out our gradients. So to work out our gradient we have to differentiate our quadratic. So we're going to get our derivative, dy dx, and that's equal to 2x take 2. So from here we're going to input both of our x values, that one, as well as that one, and then we're going to be able to evaluate our derivative at both of those points. So let's go about doing that. Let's start with our derivative at 5. So we've got dy dx evaluated when x equals 5 is equal to 2 times 5 subtract 2, which is 8. Cool. And we're going to have dy dx evaluated when x equals -3, which is also going to be equal to 2 times -3 minus 2, which is equal to -8. So what we can say is finally we can go at -3, 0, dy dx is equal to -8, and at 5, 0, dy dx is equal to +8. Now this makes sense that they would be just opposite gradients, because quadratics, if you remember, are symmetrical. So the gradient on this side is going to be similar, or well, it's going to be exactly the same as the gradient of its equivalent point on this side, but negative, and that one will be positive. So I hope this video helped, guys. It's quite a basic question. I thought I'd just run through it this morning because I've had a few queries about it in some of the homework that I've been setting, but just keep working through problems like it. You can probably make up problems for yourself, but if you've got any introductory calculus textbooks, they should have problems like this in it. But just keep practicing them, guys. If you see them in tests, it's a good couple of marks that you can guarantee yourself. But, just go through them, go through them, go through them. Keep enjoying it, though, and I'll see you next time.